Question 6 from Section 1 of the 2024 National 5 Physics Exam from the SQA. A pulse of light from a laser is transmitted from the Earth to the Moon. The light reflects from a mirror on the Moon and is detected back on the Earth 2.6 seconds after being transmitted. I'm being asked to find the distance from the Earth to the Moon. Let's take a look at a picture of what's happening. You can see there's the Earth. And we have the Moon here, and it's going to take 2.6 seconds for the signal to travel to the Moon and back again, which means the time it takes for the signal to travel from the Earth to the Moon will be half the 2.6 seconds, which will be 1.3 seconds. So now know the time it takes to go from the Earth to the Moon. To find the distance, we use the equation distance is going to equal to speed times the time, and the speed of the pulse of light must be the speed of light, which is going to be 3 times 10 to the power 8. So we've got distance d is got to equal to 3 times 10 to the power 8 metres per second, multiplied by the time it takes to go from the Earth to the Moon, which is 1.3 seconds. So the distance d, if we do that with my calculator, comes out to be 3.9 times 10 to the power 8 of metres. So d equals 3.9 times 10 to the power 8 metres, and that will be the following answer, which will be D, 6D. Question 7 from Section 1 of the 2024 National 5 examination from the SQA. The table shows the altitude and period of 4 satellites. You're given the 4 satellites here at the International Space Station. Altitude 408 kilometres and period 93 minutes. The Apries Sat-3, you're given the altitude, but you're not given the period, and that's what we're going to try and find here. Intelsat and Hubble Space Telescope are given the altitude and the period as well. So we're going to try and find a sort of kind of link between all these ones. All you have to do is just draw out the table again, start with the altitude. So 408 will be the kilometres, and that's going to give you a period of 93 minutes. The next one in that list is going to be 537. So I'm just going up in the natural order. 537 comes after 408. It's going to give us a period of 95 minutes. And then we go to 686 in the order, and that's what we're going to try and find. And then we have got to go for the 35801 kilometres above the Earth's surface, 3580 kilometres, and that's got a time of 1440 minutes there. Now you can see that the Apries Sat-3 is at 686 kilometres, so it's not going to have a period greater than 1440 minutes. It's going to have a period greater than 95 minutes. We're looking for something bigger than 95 minutes, but smaller than 1440 minutes. So we go down here, it's not 85 minutes. It can't be 94 minutes. 98 minutes looks correct here, so I put in 98. You can see the pattern is roughly in concordance with the altitude here. It's not going to be 144 minutes, and it's definitely going to be 1630 minutes. So just by doing the table in order, I can see that the 686 kilometre one is going to give us a period of 98 minutes. So the answer for that is going to be 98 minutes in here, and that's going to give us answer C. Question 8 from the multiple choice paper. A student makes the following statements about the universe. Statement 1. 1 light year is the time taken for light to travel from the Sun to the Earth. Statement 2. The approximate age of the universe is 13.8 billion years. And Statement 3. The Big Bang Theory describes the origin of the universe. So just take each statement in particular turn. Statement 1. 1 light year is not the time taken for light to travel from the Sun to the Earth, because it's the time it takes light to travel, distance light travels in the course of 1 year. So Statement 1 is wrong. The approximate age of the universe is 13.8 billion years. If you do your background reading on that one, that is correct. The universe is approximately 13.8 billion years old. And Statement 3, the Big Bang Theory describes the origin of the universe. And that's true. It describes how the universe started off as an infinitesimal small little dot, and then it expanded into what we have today. So we've got Statement 2 and Statement 3 correct, and it looks like we're going to have an answer there of 8D. Question 9 from Section 1 of the National 5 exam. An electric field exists around 2-point charges Q and R. The diagram shows the path taken by a charged particle as it travels through the field. The motion of the particle is shown there, so we'll just draw in the particle P and that's the particle P, then that's the path it takes through these two charges. Which row in the table identifies the charge on the particle and the charge in Q and the charge on R? Well, if P is attracted to Q, if P moves along as a bent in towards Q, we must deduce that particle P and the charge Q must be different charges. They must be opposite charges for attraction to take place. So if we've got positive, we're looking for negative. So it could be A. Negative, negative, rules that one out. Negative and positive, it could be that one. Positive, negative, it could be this one. And positive and positive, we rule that one out. But once again, it's this positioning here, it's bent down the way after being attracted to Q. It's even attracted more by R. So obviously P and R must be the opposite charges. If it's going to be attracted to R as well and then moves on its way, it's because it's probably momentum is taking it further along. So P and R must be opposite charges. So we've got P, particle, positive, negative, opposite charges. So it definitely could be A. We ruled out B. C, negative, negative. Well, that's wrong because they must have the opposite charge. For D, the other possibility of D, positive and positive, that's ruled out because once again they must be opposite charges to attract. So we're just left with one, and that's this one here, answer 9A. So the charge of the particle is positive, the charge in Q will be negative, so the particle P is attracted in here, it's bent in towards this region here, and then of course it's bent towards R because R's a negative charge as well. So the answer to this difficult question is going to be 9A.